NMB cable is a common type of non-metallic sheath cable used in residential wiring. It is important to understand the temperature limitations of NMB cable to ensure safe and compliant installations. NMB cable has a maximum conductor temperature rating of 60 degrees Celsius. This means that the conductors within the cable are designed to operate safely at temperatures up to 60 degrees Celsius. Exceeding this temperature rating can lead to insulation breakdown, conductor degradation, and potentially hazardous conditions such as short circuits or fires. Electrical fixtures, such as lighting fixtures, are often marked with a temperature rating that indicates the maximum temperature that the fixture's wiring compartment can reach during normal operation. Some fixtures, particularly those that use high wattage lamps or are enclosed in tight spaces, may have a temperature rating of 90 degrees Celsius. It is critical to ensure that the wiring used to connect to these fixtures is suitable for the fixture's temperature rating. Using NMB cable, which is rated for 60 degrees Celsius, on a 90 degrees Celsius fixture would violate electrical codes and could create a safety hazard. The high temperature in the fixture's wiring compartment could cause the NMB cable's insulation to overheat and degrade over time. This degradation could lead to insulation cracking, which exposes the conductors and creates a risk of short circuits or electrical shock. To comply with electrical codes and ensure safety, it is essential to use wiring that is rated for the temperature of the fixture. If a fixture has a temperature rating of 90 degrees Celsius, you must use wiring that is specifically designed and rated for 90 degrees Celsius applications. There are several types of wiring that are suitable for 90 degrees Celsius applications, including THHN, THWN, and XHHW. These types of wiring have insulation that is designed to withstand higher temperatures without degrading. When selecting wiring for a fixture, always check the fixture's temperature rating and choose wiring that is rated for at least that temperature. It is also important to follow all other applicable electrical codes and regulations. Some other considerations that are important with NMB cable is its ampacity. Ampacity refers to the current carrying capacity of a conductor. It is the maximum amount of current, measured in amps, that a conductor can safely carry without exceeding its temperature rating. The ampacity of NMB cable depends on several factors, including the size of the conductors, the type of insulation, and the ambient temperature. The National Electrical Code, or NEC, provides tables that specify the ampacity of different types of conductors under various conditions. These tables are essential for determining the appropriate size of NMB cable for a particular application. When determining the ampacity of NMB cable, it is important to consider the ambient temperature. The ambient temperature is the temperature of the surrounding air. As the ambient temperature increases, the ampacity of NMB cable decreases. This is because the conductors in the cable generate heat as current flows through them. If the ambient temperature is already high, the conductors will not be able to dissipate heat as effectively, and their temperature will rise. To compensate for the effects of ambient temperature, the NEC requires that the ampacity of NMB cable be adjusted using correction factors. These correction factors are provided in the NEC tables and are based on the ambient temperature. It is also important to consider the number of current-carrying conductors in a raceway or cable. When multiple current-carrying conductors are installed in close proximity, they can affect each other's ability to dissipate heat. This is because the heat generated by one conductor can raise the temperature of the adjacent conductors. To account for this effect, the NEC requires that the ampacity of NMB cable be adjusted using directing factors when there are more than 3 current-carrying conductors in a raceway or cable. These directing factors are also provided in the NEC tables and are based on the number of current-carrying conductors. When installing NMB cable, it is important to follow all applicable electrical codes and regulations. These codes and regulations are designed to ensure the safety of electrical installations and to prevent electrical hazards. Some important considerations when installing NMB cable include ensuring that the cable is properly supported and secured, that it is not exposed to physical damage, and that it is not installed in wet or damp locations unless it is specifically rated for such locations. It is also important to use the correct type of connectors and fittings when terminating NMB cable. These connectors and fittings are designed to provide a secure and reliable connection and to protect the conductors from damage. When working with electricity, it is always important to take precautions to protect yourself from electrical shock. These precautions include wearing appropriate personal protective equipment such as rubber gloves and safety glasses, and ensuring that the power is turned off before working on any electrical circuits. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. In summary, an NMB cable is a versatile and widely used type of wiring that is suitable for many residential applications. However, it is important to understand its limitations, particularly its temperature rating and ampacity, and to follow all applicable electrical codes and regulations when installing it. One must always use wiring suitable for the fixture's temperature rating. To reiterate, an NMB cable cannot be used on a 90 degrees Celsius fixture because it is only rated for 60 degrees Celsius. The potential dangers of using an NMB cable above its rated temperature include insulation breakdown, conductor degradation, short circuits, and electrical fires. The NEC provides guidance on ampacity, correction factors for ambient temperature, and rating factors for multiple conductors to ensure safe installation. Furthermore, always follow local codes, secure the cable properly, use the correct connectors, and take precautions to avoid electrical shock. If you are unsure about any aspect of electrical work, consult a qualified electrician.